Hi guys, welcome to LEI Electronics Repair. This is turned up on my bench. So, I've not seen one of these before. This is an LED light engine, LEI DMX. Something shiny down there. Okay. The model number, it does have one, LEI-8001DMX. LED 1 to 80 watts, okay? As soon as I saw this, I asked him, is this a disco light? He said, no, it's a fibre optic light, okay? The company who brought it in are builders and renovators. They do a lot of work and updating on housing and villas and whatever around here. So this is the same company a while ago brought me some controllers for swimming pools and jacuzzis that I fixed, okay? So he asked me if I could look at this. I was a little bit puzzled exactly what it does. So I found the user manual, light engine user manual, okay, wireless remote controller. Yes, it does have a wireless antenna on the back of it, by the way. Welcome to the use of LEI series professional light engines, yeah. DMX is a standard for controlling lighting, by the way. So it has a number of channels. This will have several channels. So one channel will probably alter the brightness, one will alter the colour, etc, etc. Maybe one is for strobe on and off. It sort of shows this being used to make like signage, something like that maybe. So perhaps that's what it actually does. It describes the remote control, how to connect them together, master slave. If you've ever wondered, by the way, DMX is a very simple method of controlling up to 512 channels. So one light can have, you know, one channel, 10 channels, whatever. And the way it actually works is there's no addressing of the devices. So basically, the DMX controller repeatedly over and over again sends out a sequence of bytes. So there's like a starter byte that says this is the start, or some sort of signal says this is a start. And then each byte is a value. So you can have 256 values from 00 to FF. And the way the device actually knows which byte of data is for itself, for which channel, is it counts the bytes from the beginning. So if you have, for example, a light which is addresses 10 to 15, for example, it will count the first 9 bytes, it will ignore them, and then the next one, 10, it will say, oh, that's for me, and so is 11, 12, 13, 14, and 15, and then it will ignore all the ones afterwards. And the other ones can go to other devices. An interesting upshot of this, by the way, if you're ever setting up DMX, is you should have the bytes sequential. You shouldn't have like maybe a device on address 1 and one on 5 and one on 10 and then one on like 300, because what would happen is then the controller has to send out the data to the first 3 devices, and then like 200 and odd bytes all null before it gets to number 300 and on, which is the other device. That makes the chain of bytes longer. The chain length will depend on how many channels are being controlled, and that then obviously having to send all these null bytes reduces the refresh rate. Okay, so a little bit about DMX there. If you want to know a bit more about the DMX, or that wasn't any clearer than mud, ask me in the comments below and I'll try to explain it better. Okay, so that's what we basically have here anyway. This is effectively as a powerful RGB, maybe RGBW, LED, maybe something else, maybe just a single colour, and it shines out of here into the fibre optics. So the only thing that can really go wrong with this is it doesn't light up. Unless it does light up, but the controller, the DMX function doesn't work, so you can't control it. But that ain't a very common failure mode, so more than likely it just doesn't light up. I'm looking on the back, and actual fact it says it's 100 watt and it's 6 colours. So there are 6 colours in this. Normally that's red, green, blue, white, and then sometimes ultraviolet and yellow. Okay, it could be something different, but that's usually what they are. Okay, I think we can plug this in quite safely. He didn't say it goes bang or anything like that, so I would normally have a look inside first. In fact, you know what, actually, let's just have a look inside first to make sure it's safe to plug it in. You can see somebody's unscrewed this before to have a look at it, and if it looks okay, yeah, let's plug it in and see what it does or doesn't do. Oh, if you're interested to know, is this worth repairing, by the way, I'll just show you. So we can buy these from AliExpress, and it's $343, sorry, euros, plus another 70 euros shipping. So this is going to cost a bit over 400 euros to replace, and you're not going to see a replacement till mid-late August, okay, and it's now the 3rd of July. So I would suggest this is well worth repairing for at least 2 reasons, okay, cost and time to replace it. Let's see what we have. Well, the lid comes off. We have what looks like a linear transformer here, power, if that's what it really is. Doesn't look very big for 100 watt. Oh, no, there's another power supply here. So this is a switch mode power supply. This is a, maybe not a mains transformer. Is this connected somehow into the, not sure. Thought maybe connecting to the DMX as isolation, but I'm not sure about that. We have a great big heatsink here with no doubt the LED is in there. If that's failed, that could be the expensive thing, so that will pretty much decide whether or not this is worth fixing or can be fixed. Okay, and then we have a controller down here. So this will be controlling the 6 LEDs in here. Okay. Let's see if the fuse is all right. Yeah, fuse looks good, nice, clean, looks fine. I'll just test it. Fuse is good. Okay, so probably this is a constant current supply for the LED, and this effectively is the switching that controls the different colours. Let's plug this in. If we're lucky, it might just be dead, like we have a problem with the power supply. If we're unlucky, it'll power up and this thing will move around, but it won't light up. Let's see, what do we have? Yeah, it powers up, that moves, and it doesn't light up. It could be there's one power supply for the motor and another power supply for the LED, and the LED power isn't working. If I take this side off, we can have a look to see. I'll just unplug it from the mains for safety, by the way. We can see what power should be coming out of this power supply and see if it is actually correct. We can see a little bit further inside it now. While I was just unscrewing the case, it seems a bit strange. If this has a 6-colour LED, that effectively none of the colours are working, because it would be separate LEDs, unless there's something here that's like a colour wheel. This isn't. This just has holes in it. Okay, there's no, it's not like a colour wheel. It has like a little sensor here, look, so it knows where the 0 position is. It has a stepper motor down here with another little controller that goes, I think, to the stepper motor. The wires are a bit tangled up and it goes under here, I can't see, but it looks like we have mains going into this transformer and mains going into this, so we do effectively have 2 power supplies. This then 2 yellow wires comes, it goes under here somewhere. I'll have to take this fan out so I can see where it actually goes, but that's not going to be easy because it has nuts on, they're not captive. But that goes under here. Almost looks like a mains here, you know, either neutral on this board, but I'm not sure that is, and I can see the same there. So I'll just need to try and figure out how this is actually connected up. Okay, so I've actually just disconnected the panel. That was the easiest rather than trying to take this off. Now we can see something. So we have mains coming in here. This is the primary of this transformer. That then goes off down here in this wire. That is actually then going to the brown and blue ones here by the looks of it. So I think that effectively just those yellow wires just join somewhere down here. Okay, this looks like it goes, let's see. Let's be certain. Okay, right. This one goes under there. That one goes under there. Okay, there's 1, 2, 3, 4 wires. Let's see, where does all this go? Okay. Yeah, that's the power coming in. So to here. This is your DMX. We can just unplug that for now. Yeah, get in there. So that definitely is the power coming in. That one. Is it marked on the PCB? You know, I'm going to have to take this other panel off as well to have a look. So pretty much dismantle this thing. Okay, now maybe we can see. Of course, the whole thing is now falling to bits. Right. So there's no markings on here. You'd assume that's AC coming from the transformer, so there must be a bridge rectifier or something like that under here. I don't see anything much in the way of smoothing capacitors. I would expect to see a fairly big smoothing capacitor. It's a tiny one there, but maybe this isn't really generating much power because this goes to the LED front display. Okay, and this one goes to the stepper motor, and then this one goes to the sensor. Yeah, so all this board here is doing is controlling the stepper motor, and then we have here LED power. Okay, and this one is not marked. That's the one that goes under there. LED power also goes under here. Okay, and the other one that goes under here, this one comes from the big power supply. Okay, so we have LED power, we have another one that goes under there, and then we have this one that goes to here, and this is the mains going to the power supply. So it's possible that this is powering up and this power supply isn't running. Let's have a look. It is obvious, by the way, that this LED power here, this can't be powering the LED, because this, no way can this handle enough power for that 100 watt LED. Yeah. So this, if anything, is like a control signal, maybe the brightness level of the LED, something like that. So the output of the power supply here, we can see is marked V minus V plus. Okay, you can probably see it there, V minus V plus. So this is just a single supply rail. It has an adjust. Let's see what we have coming out of that power supply. I'll leave this DMX disconnected, don't need that for the moment anyway. Let's power this up again, so the switch is on, plug it in. Okay, little wheel going round. What's coming out of the power supply? So V push down here. This won't be a high voltage power supply. 15 volts. I'm a bit concerned about that, because if this is powering the LED, I'd expect the LED to have a lower voltage than that anyway, so maybe it's not drawing any current because it's faulty, and this effectively is just ramping up the voltage because the constant current source is trying to get some sort of current. Or it may be that the LED in here does run at that sort of voltage, it's got supply and it's faulty. Yeah, we have the other signals over here. So we have this LED power. I'm interested to see what's on these other two wires that go under there. Okay. There's a red LED on this, by the way, the red LED down there, just out of interest. Oh, the front display is flashing as well. I hadn't noticed that before. We can look at that in a minute. Yeah, it's just saying P05 now. That's probably like one of its built-in programs. Let's see. So that has no voltage on it, basically, on LED power. In fact, very slightly negative. This one, -4. So the red and black are not the way I would have thought they would be. 4.5, nothing. The front panel display is now gone out. I'll just show you again. I have to just make this a little bit bigger. So that's now gone off. There's a built-in microphone on this, by the way. Switch it off again. Give it a few seconds. So it's saying reset, RES, reset. Yeah, it's going to move the wheel around till the little peg comes into the position. And here, P09, that'll be one of its programs, not P05. Yeah, the wheels now move, look, as I'm hitting the button on here, program 0807. You know, the up button doesn't really seem to work. The down button works, but the up button doesn't. That's another problem with this. Well, remember that setting. Reset. I can watch the little peg come round on here. Right, now it's reset. And it's back onto P06, which is the last one I set it to. And the up button is faulty, I would say. Okay. I'll just check with the user manual, but I'd expect that this program 06 should have some sort of light. That moves this wheel to a different position. Moves again. Program 2. Program 1. 0. Yeah, that's moving on that program. Yeah, program 11. 10. 9. Okay, well, if the up button isn't working, I can move it around. So program 9 is that one, just rotating. Okay, so either we've got some problem with the signals coming from here to control the LED. It appears to have power, or we just have a duff LED. How do we figure out? Well, again, that has basically nothing. I'm just checking again. 4.5. That looks like some sort of enable voltage, enable signal, and I'm not sure this has LED power. Maybe this affects the brightness and it's all the way down to 0. That's a possibility. Kind of like a pulse width modulation or something like that. Just referring back to the manual, so the LED is in fact just white. It says colour wheel 6 colours, but honestly mine doesn't seem to have any colours in it. Okay. Just holes. Yeah, it also shows those modes I was using. So P9 is a 6-color fade, that's why the thing is rotating. So that is an automatic program, so it should just run. It doesn't need the DMX controller to actually switch it on. In fact, to go into DMX signal control mode, you have to set up an address. It tells you here how to do it. So these are just automatic programs which we have built in. Okay, so what do we have? Do we have a problem with the controller not switching the LED on, or do we have a problem with the LED? Well, we appear to have a MOSFET or transistor here, so that looks like, very much like, that's actually going to this. I'm expecting this is probably a pulse width modulator. Then we have here a buck converter, okay. We can see this is controlling the front panel. There's a chip missing there, but maybe it's just an extra EEPROM. No, it's not an EEPROM. This thing is a ULN 2803. That's a Darlington transistor array. Oh yeah, look, there's some more connectors here like flash, color and flash. Okay, so obviously that isn't connected, so that isn't needed, I would say. On that's not that it's missing, it just was always missing by design. Yeah, just try to balance that up. So things we can check. Well, we can check that this circuit is working. So probably, if this is some sort of pulse width modulator, this supply may be related to that. It's all sort of down here. So let's see what's on this coil here. That looks like a voltage regulator. Let's have a quick nosy, see if at least it looks like it's sensible. Trying to figure out where ground is. Well, this chip has probably got a data sheet, and if we can figure out which pin is which, maybe from that we can figure out where ground is. In other words, like the ground for this chip is the same as the ground for everywhere else on here. Same with this regulator here, maybe a data sheet from that will tell us where ground is. Okay, that is a strange, TD1501S50, okay, and PT2272. Let's look for some data sheets, because there's nothing particularly obvious at the moment where ground is. I mean, there's some big tracks around here, around this capacitor, but I don't see anything particularly obvious at the moment. Same with this 18 mega, I'm sure that will tell us where ground is. Okay, so I've gone for the voltage regulator because I'm interested to see what voltage we have here anyway. This is the TD1501S50 is the one I have. I think the S50 is the 5 volt version by the looks of it. There's a 3.3 and an adjustable version as well, so I think we can say mine is the 5 volt version. And the first thing we can see is the ground is on the middle pin, so at least we know where ground is. Yeah, look, 50 is the 5 volt version. So that's a 5 volt regulator, and the output is on pin 2. Okay. Okay, so we know this is ground. Yeah, it goes to the bottom end of that chip where you'd expect the ground pin to be. Is that the same as here? Oh yeah, it looks like it. Okay, so the tab is ground. So that's a nice, easy place to measure ground. This looks like it comes down to this buck converter. I'm pretty confident this 5 volt supply will be there because everything else is powered up. Could still be a problem in the switching devices down here. Or again, the problem could be with the LED. It's rather difficult to keep this thing stable actually. Let's see what we can find. So once again, on ground is here. What's on the coil? 5 volts. So that's running. Happy with that. Right. It's easiest, I think, to get this board off, and let's just have a quick look around these power devices. I mean, if something's going to fail on here, it's probably that. And if we can't see any problems with there, then we have to get this LED off, see what it is, and see if we can find a data sheet and figure out some connections and see what we think, yeah? Well, I have the PCB here. It was certainly worth taking this off because it shows us a few things. This is a LM317 voltage regulator. This one, I'm struggling to see down there actually to see what that is, but I'd say some sort of MOSFET or transistor. Now you see you've got power and LED here, and those connect directly across 2 pins of this. So from the standard layout, this would be the gate or base, and then power is coming in on here and back out on there. So this isn't powering something on the LED, it's effectively in series with it, so it's supplying power to it, but the power is not coming from this board, which I said doesn't have enough power to power the LED. It's just passing through here. Let me just draw that. So we have the PSU, what was it, 15 volts. Okay. V plus, V minus. 15 volts or thereabouts, okay. This, let's just say this goes to ground. Okay. Then the V plus looks like, because it all disappears under the heatsink where the LED is, but looks like it comes onto our PCB. So this is the controller, this is what's driving the stepper motor and such like, called the DMX. Goes through that device, I'll draw it as a MOSFET because it probably is, and then goes back under the heatsink. So this is the part that I can't see where the wires are actually going, and this is your LED, probably going to ground. Okay, 80 watt or whatever the thing was. If that's what we have, and I don't see any large power resistors on here, so if there is a resistor in the circuit, it's somewhere else, probably under that heatsink. If we drive this MOSFET with pulse width modulation, that will control the brightness of the LED. Now I was previously measuring from there to there and finding 0. Now if our MOSFET is switched on, basically, so 100% duty cycle, or close, we're going to see 0 volts across it. In fact, we'd only measure a voltage across here if this wasn't on 100% duty cycle. So the voltage going to the LED is lower than the voltage coming in. And then we would measure the voltage and we see 0. So that kind of tells me either A, the MOSFET is switched on, or B, that this is open circuit, okay? Because if the LED is open circuit, then no current will pass through it, so we'll have the same voltage either side of this, regardless of whether that's switched on or not, basically. Let's have a look. And we can test this 2 ways, I think. Firstly, it doesn't appear to be connected to anything else in our circuit apart from the gate, if it is a MOSFET, okay? So if it's a MOSFET, from gate here, should read open, open, and then in the reverse direction we'll see a parasitic diode here. Not that way, but that way, okay. So it is a MOSFET, and we can test it because this is not connecting to anything. We should be able to test this in circuit, no problem. Just stick a couple of probes on these two. Attach this one to the gate. We'll hold it on there. Hit test. MOSFET, and it's good, okay? So We know that's good. It makes sense we see 0 volts across here. We would have to measure from here to ground to see a voltage. Now, the 2 wires that go down to our LED, which are these ones, one of them is the supply coming in from the power supply, and the other one is going out to the LED. Now, you wouldn't expect either of them to read short to ground. Okay, so I'm trying to find a ground point. I'm hoping chassis is ground. And if it did read short to ground, I think the MOSFET would blow up or something. So that just reads open. I don't see any. If I go from here to V minus, so that end connects to V minus, shorted effectively. So then go to V plus. No, we can't go to V plus. Oh, it looks like, guys, I have this the wrong way round. In fact, it makes sense I have it the wrong way round in actual fact. Because otherwise, you'd be difficult to control the gate voltage on here because this would change. So I'd say what we actually have is this. V plus, V minus, okay. This goes to ground. Then V plus goes through the LED. Okay. And then this end goes to our MOSFET, and this then goes to ground. Okay, like that. The same would apply if we measure across here, from here to here. The MOSFET is switched on, we'll see 0. Okay, but one of the wires will go to ground, and that's what I'm seeing by the looks of it. So this end, not ground, but V minus, okay, isolated from ground. Yeah, the blue one, okay, goes to V minus. And the red one will be coming via the LED, okay, from V plus. So we won't see any connection there, but if I switch this on and measure the voltage from here to here, if the LED is conducting anything else, we'll see a voltage. I'm interested. I mean, the LED will be off because there's no current path, but you'd expect some small amount of current to flow through it. Okay, I've attached my meter leads across here. So we know that the brown one is effectively the anode end of the LED, which goes to this MOSFET, and then that goes to ground. So it's pulse width modulating, it's just controlling the current through the LED. So if I see 0 volts across here, I can say that there's getting no positive voltage to here. So either the LED is open circuit or the wiring somewhere between the power supply, the LED, and here is open circuit. Is there a fuse buried in there? I doubt it, but we'll see, no doubt, if that's the case. If I measure a voltage here close to the power supply voltage, then probably the LED is okay. I mean, I don't know what the voltage drop is across this LED, even when it's effectively pretty much 0 current flowing. So I might see some voltage here that says there's some sort of connection. Doesn't necessarily mean the LED is actually working. So let's have a look. We'll just power this up. And I don't see any voltage, okay? So we can say that there appears to either be the LED itself as open circuit, or there's no current path here, like, you know, broken wire or a fuse or something under there. I'd be very surprised if there was a fuse. Most likely this is the LED, but we need to find out. So what we have to do is take this apart to see where these wires actually go. I've removed this now, and it's very satisfying to see that the analysis of the way this is wired up is correct. So we can see here, this is the positive coming in from the power supply. Okay, that's over here. This one. So this is positive, then the negative goes down the brown wire to our MOSFET that controls the pulse width modulation. And then the other wire, you can see, comes back up here and is soldered here. The blue wire joins there. We know that's connecting to ground because we tracked it through. Yeah. These look firmly pushed on here. I mean, we can absolutely double check. So if I just loosen them slightly, okay. But I don't honestly see there's a chance of being a bad connection here, but we have to check everything, yeah. Okay. So V plus from the power supply comes in here. Okay, and then minus here. Goes to the brown one. And then the blue one, we already know, goes back to V minus. Okay. So all that's left is this. Let's have a look. There's just two connections on it. I can't test this with the multimeter. It won't do anything. It'll read open because it has like a number of LEDs in sequence. So even in diode mode, this can't generate enough voltage to test it. Okay, just reads open. But I could test it. I mean, we're pretty sure it's faulty, I think, but I could take my bench power supply, connect it to here, set the current limit, 20, 30 milliamps, something like that. That's probably a good initial current to go for and see what happens. Okay, that's one possibility. The other one, and easier for me because I happen to have one, is to use my backlight tester. So this is an LED light source tester. It has two ranges, 1 milliamps and 30 milliamps. Now, if I just power this up on the 1 milliamp range, you'll see it goes to 21.6 volts. So that's more than enough to test this. If I short the probes together, it'll just go to 0, and we'll have a 1 milliamp source. So let's put this across our LED and see what it does. Well, it reads 21.9, so effectively it's open circuit, it's not doing anything. The other thing, then we go to the 30 milliamp range. This will now go up to 320 volts. Okay, 326. Again, I can short these together, it won't do anything nasty, it just goes to 0. I have 30 milliamps. But guys, do not touch the probes when it's on this setting, okay? I've just angled that slightly so you can see it easier. Now you may think putting 320 volts across this would just destroy it, but it won't, because this is a constant current source, so the voltage will drop, just like when I do that, to whatever voltage the LED drop is at that current. So does it light up? Well, it flickers. Yeah, it flickers, but it doesn't light up. Okay, in fact, it doesn't light at all now, it just flickered a little bit. So that is a dead LED. I'll just prove actually that that tester will not damage the LED. So this is a 90 watt RGB LED. I've got a feeling the positive is the common one. So again, we put my tester on it. See, it lights up. Red, green. And the voltage is dropping to about 23.5. Blue. Okay, so it won't actually damage it. This LED is just no good. It's a little flick and that's all we get out of it, okay? It flicked again, so it hasn't destroyed it or anything, okay? Now you will notice, if I put this in a position where you can see it a bit more easily, that on this LED, that blue is saying about 25.2 volts, 23.4 volts, 17.9. Okay, so that's the voltage drop across this. This is a 90 watt LED, but each segment is 30 watts. I don't have any more powerful ones or powerful white ones, unfortunately. If we go back to our faulty one, we get a quick flicker. Can you see it flickering? Maybe. I'm not sure how well that comes out on the camera. Let me just turn off the overhead lighting a moment. There. Okay, and it's reading on my meter 324. Oh, the thing popped out. I have these needles in when I'm fixing things like Christmas lights, by the way. But effectively, that is saying, even at that sort of voltage, it cannot get enough current through here to pass 30 milliamps, okay? But what we do know is that the power supply on this unit, this one, is giving about 15 volts out. Now, all the LEDs I've just tried were dropping more voltage than that. So if the voltage is less than 20 something on the green and blue, which is much more similar to the voltage drop on the white, especially the blue, okay, if the voltage is less than that, this wouldn't light up. So it does seem a bit strange I only have 15 volt supply. Now, this is a much more powerful LED, and I don't have a lot of experience with them, but what I am wondering is whether my LED tester at 30 milliamps can't actually provide enough current for this thing to actually light up and start passing current properly. So what I'm going to do is connect my bench power supply to it. I'll set a current limit, let's say 500 milliamps, something like that. I mean, I'm sure this draws, well, what is it? It's a 60 watt LED at least, from what we know, and it's a 20 something volt supply, which is what I think it really should have. But, I mean, I don't know. It will depend on the construction of this and how these are effectively internally connected. But at say 20 volts, this should draw about 3 amps, something like that. If it really is a 15 volt supply, more like 4 amps. So if I set my bench power supply, say to 500 milliamps, at 15 volts, connect it to this, and then see what current it's drawing. I'm going to increase the voltage supply to see if it will actually come on as a higher voltage. Could be clutching at straws here, but hey, you never know. Okay, so I'll short the leads of the power supply together, switch it on. I'll turn the current actually down, so we're in constant current. The red LED is on 150 milliamps, and I'll turn this up, as I say, to about 500. Yeah, we're close enough there. Okay, stick this on. On the outside chance this actually does work, it means that the power supply is faulty, not giving enough voltage, and that my LED tester can't effectively light this at 30 milliamps. I'm a bit surprised if that is the case, but hey, there's nothing to lose, yeah. So what do we have? Well, that says no current is flowing, so effectively it's like open circuit, okay? So let's take the voltage up a bit. And somewhere around here, maybe. Well, we're up at 30 now and it's still passing no current. So basically that is open circuit. I mean, it's going to work at less than that, yeah. I mean, we might have got 10 milliamps out of it just there, so yeah, if we continually alter it, we get maybe about 10 milliamps. Oh, and it's actually lighting up a little bit. Look, let me show you. No, it's not. I thought it was. It must have just been reflection. I was moving my head. Okay, so we can say that LED is definitely faulty. So we need an LED. Well, I've tried to get this off here. There's like a flush edge, so there's no like lip under here, and I can get. No, I can't even get under here, not easily. I'm sure if I just try to prise this, I'll just break it. Yeah. There's nowhere to get in. Under there? No. I mean, I could try just hitting this with a hammer, maybe. This appears to be bonded on here. Okay, you can see. So, like, that is a reflection because this is very reflective. Okay, so this is the metal. So what we see after that is just the reflection of it. I doubt it comes like pre-assembled with that heatsink as one part bonded on. Let's look at the number. I think it's more likely glued on in some way. Yeah, I think there's like some sort of cement paste under there. Let's see if this number finds anything interesting. Well, LED plus that number doesn't seem to bring anything. Just search the number. No. This might be what's known as a Cree LED. So we can try that, see if that helps. No. No. I'm seeing if I can find one of these LEDs another way. So this is the unit in black, but it's the same thing, okay? Oh, this is what it sort of does, by the way. It says the LED type is 55 watts Cree XPL. It does say, this comes with a colour wheel or a twinkle wheel. I think we have the twinkle wheel or a colour twinkle wheel. That's why we don't do any coloured things on ours. It must be the twinkle version. Well, I've had a look around on various search terms, XPL wide, Cree XPL, 55 watt XPL or 55W XPL and various other ones. But I can't find anything that looks like that. I've tried all the various combinations of Cree and white and 55 watt and XPL and all the other things I can come up with and didn't get anywhere. I was just about to give up, or rather ask you guys, but I noticed that this actually has a brand written on here. It's rather hard to read, but if I put a bit of coloured stuff on it, you'll probably see it. They are flat light, spelled PH. Yeah, flat light. So I have now searched for that. I've tried flat light with the number 0610146697. Doesn't help particularly, although it does bring these links up. Okay, AliExpress there. But also I tried flat light 55 watt. Which according to the user manual, this is 55 watt. Okay. LED has been searched for before. And that basically brings me to the same link or links on here, okay. So it doesn't mention 55, 2060, 75, 2060, 2060. So they all basically seem to be for the same sort of device, okay. And if we look at one of these, there's a lot of different models, and that's a 20 watt, 90 degree, 90 watt. So there's the different angles and the wattage. And the last one I find is this one. So that has like the blob on there, the lens thing, but it has 6 sets of LEDs in there where mine only has 4. Okay, SSD 90 says it's a 60 degree, 60 watt, so that might be something like what I want. I couldn't say for certain. This thing is €16. So my best guess, if I'm going to replace it, is probably one of those and hope for the best. Okay. There are other listings, but they don't really take me to anything particularly different. Non-loop, just like the one I have, yeah. Those are actually higher wattage. I do know what the colour temperature should be because it told me on that user manual, but interestingly this one then doesn't tell you. So it's kind of 6 of one and half a dozen of the other. There's another one here, but this one is 90 watts as the minimum, so it's not the same rating. Look, it has different mounting holes. Okay. And the other question, of course, is how do I actually attach this to the heatsink, even if I was to get one? So I can suggest to the owner that we try that, but before we do, does anybody know how to get this off here? Yeah, I mean, other than my suggestion, hit it with a hammer and something like a chisel down there. Yeah, I can't see how that comes off. I don't suppose something would dissolve it either. I mean, it seems to be bonded all the way behind there. And also, I'm guessing whatever it's stuck on has to be a good conductor of heat as well. So, there's a few things I don't know about this, but you might. Yeah, you might know. So, if you do, can you please let us all know? If we've gained nothing else from this video, at least we've had a look how to diagnose the faults on these sort of lighting equipment. We know effectively how this works, and I'm pretty sure other works very similar. We've worked out how to prove that the rest of the components are basically okay, and we are down to that. So the diagnosis is good. It's just now A, getting the right part, and B, how the hell do I fit it on there? Okay, well, hope you enjoyed this anyway. I look forward to hearing you down there. And if you do know the answer to this one, I'm sure lots of other viewers want to know as well. Okay, thanks for watching Learning Electronics Repair, and I'll see you all soon. Ciao for now, guys.